Hi, so for today is we will talk about isotopes and nuclear decay. So when we talk about isotopes, so it is a term used by scientists and also chemists and physicists to call a variation of an element. So kapag po sinasabi nating isotopes, so these are elements having the same atomic number but different atomic mass. Okay? Hindi po nagbabagong element. Okay? Pare-pareho lang pong mga element yan, pero magkakaiba po sila ng timbang. Halimbawa po, you have here the isotopes of hydrogen. So, for the first isotope is we call it as protium because it contains one proton and electron. Now, as you increase or as you add the number of neutrons, yan, so dun po nagbabago yung tinatawag nyong atomic mass. On which, when you add neutron, so it will become deuterium. Now, if you're going to add another neutron, it will become a tritium. Another example of the isotopes natin is we have the isotopes of carbon. So we have carbon 12 which is considered stable, carbon 13 which is stable, and carbon 14 which is unstable. But what does it mean when we say an isotope is unstable? Take note of this one. So not all isotopes are stable. So some of them are unstable. So, kapag sinabi natin unstable, so yan yung mga isotopes natin na pwede mag-breakdown, pwede mag-decay, or pwede yung mag-emit ng tinatawag nating radiation. Pero ano ba yung nagkakos sa mga isotopes na to para maging unstable? So, siguro, one of the reason is that they have too many protons or they have unstable ratio of protons to neutrons. If an element has an unstable isotope, it undergoes a process known as radioactive decay, or in other terms, we call it as radioactivity. We have different types of radioactive decay. So we have primarily three. First one is we have what we call alpha decay. So when we talk about alpha decay, it is a process where an unstable chemical element releases a helium nucleus, also known as an alpha particle, from its unstable nucleus to achieve stability. Other than that, the ejected particles travel in a straight line because of its mass. Just for example, on this illustration, so we have here polonium 210. Okay? So from that polonium 210, so it will undergo alpha decay, therefore it will release a what we call alpha particle. Now, as you can see, nung nag-release siya, tinatawag nating alpha particle, mababawasan ngayon ang number ng kanyang protons at number ng kanyang neutrons. Kapag po nabawasan ang kanyang neutrons, magiging 206 na lang po yan at magiging 82 na lang po ang kanyang atomic number. Therefore, kapag po nabago na ngayon ang atomic number dahil sa pagtanggal niya ng proton, magbabago po ngayon yung identity ng element nyo. So, from polonium, naging lead na po at naka-form din siya na tinatawag nating alpha particle. Kaya po siya tinawag na alpha decay, kasi nga po, nagre-release po siya ng tinatawag nating alpha particle. So, I already mentioned to you a while ago the what we call polonium na example natin. Now, we have here the formula for the alpha decay on which X is the original element, A is the original atomic mass, Z is the original atomic number, and Y is the new element created after the decay. Now, ano ba yung formula natin dyan? So, we have here A minus 4, Z minus 2, and Y plus 4 to A. Now, ano po ba yon? Or paano po ba yon? Di ba nga po, kapag alpha decay, nag-release siya ng alpha particle. Kapag po sinabi nating alpha particle, meron niyang 4 na neutron at saka meron din po siyang 2 proton. Now, ibabawas nyo po ngayon itong 4 na neutron at 2 proton dun sa original element nyo. So, kapag binawasan nyo po yan, so 210 minus 4, magiging 206 po yan, and 84 minus 2 would be 82. On which, diba, sabi ko nga, kapag binago nyo po yung number ng proton nyo, which is also the same with the atomic number, magbabago po ang identity ng element nyo. So, on which, ito po yung pang number 82 ngayon sa periodic table. Ito po yung tinatawag nyong lead or yung PB po natin. Okay? Ganun po nangyayari ang tinatawag nating alpha decay. Subsequently, if an alpha particle is launched directly to an element, it creates a new one. and ejecting a neutron in the process. So mathematically speaking, this would be the equation that we will use. So an example of this one is the alpha bombardment of beryllium-9. So we have your beryllium-9, it is bombarded with alpha particle. So it will produce carbon-12. Bakit hindi siya carbon-13, sir? Hindi po siya magiging carbon-13 kasi nga yung isang neutron po, mare-release po siya or ma-eject yung neutron na yon. Therefore, ang magiging product niyo po dyan ay carbon-12 plus 1 neutron. Okay? Ganun po ang mangyayari dyan. So for the second type of radioactive decay is we have what we call beta decay. So when I talk about beta decay, it is the process where an unstable chemical element releases a beta particle to achieve stability. Doing this does not convert the unstable chemical element into another element. The unstable element now tries to stabilize itself by converting a neutron inside it into a proton, releasing the excess mass as a beta particle. When observed in a cloud chamber, beta decay particles travel in a curved path. The first version of the what we call beta decay is called B-decay because it ejects an electron. Kasi nga negative yon, electron after achieving stability through beta decay. As an example, given the B-decay of carbon-14. Halimbawa, meron tayong carbon-14 dito. Now, kapag nag-undergo po yan ng B-decay, hindi magbabago yung number of neutrons mo. But rather, magbabago po ngayon yung number ng protons nyo. Madadagdagan niya ng isa. Okay, kapag dadagdagan po yan ng isa, magiging nitrogen-14 po yan. And aside sa nitrogen-14 na na-form ngayon, mag-e-eject po yan or mag-produce po ngayon siya ng tinatawag nating electron. The second version of beta decay is called B-decay. This one ejects a positron after achieving stability through the what we call beta decay. Ano ba ito tinatawag ng positron? So, positron po ay mga positive po na electron. So, a positron is the antiparticle counterpart to an electron. So, antiparticle are the primary study in the field of antimatter. As an example, given is the B+ decay of oxygen-15. So, kapag nag-undergo po ngayon ang tinatawag nating beta+ decay, ang oxygen-15, instead na madagdagan yung inyong proton, mababawasan po yan ng isang proton. Or particularly, tinatawag natin mga positron. Okay? So, from 8, magiging 7 po yan. Magbabago ngayon yung identity ng element nyo. So, it would become nitrogen-15. And also, may maproproduce na tinatawag nating positron, which is 1. Okay? That is what we call beta decay. The third version of beta decay does not involve any ejection of particles. This one has the atoms absorbing its electron to create a neutron for stability. So this form of beta decay is also known as the electron capture. Just for example, you have your mercury 201, and it reacts or it is bombarded with 1 electron. So kapag nangyari po ngayon yon, so syempre, magbabago ngayon yung identity ng inyong element. So instead na maging mercury yan, magiging gold na po yan. Gold 201. Yan po ang tinatawag nating electron capture. And for our last example is you have what we call gamma decay. So, gamma decay is a process that is always active and in conjunction with the other decay processes. So, it does not release any alpha or beta particle, but rather it releases a gamma particle. A massless particle that has both momentum and energy. The energy of gamma decay, or the gamma particle rather, carries the excess energy resulting from the decay of a radioactive element. So mostly, diba, kapag sinabi natin alpha, beta decay, merong na-produce na element, nagre-release siya ng mga particles. Okay? Dito naman po, hindi siya gumagawa ng panibagong element, but rather, nagre-release po siya na tinatawag nating energy through the what we call gamma decay. Ito po yung karaniwan nyo nakikita. For example, during our discussion on the formation of the universe, or particularly on the stellar nucleosynthesis, yan, nangyayari yung tinatawag nating gamma decay sa mga elements. And also, during that what we call gamma decay, nakikreate yung tinatawag nating mga gamma particle na nagdadala ng tinatawag nating energy. Yan, so kapag po sinabi natin gamma decay, Ayan, so mostly nangyayari din po siya sa iba't ibang klase ng decay natin or kasama siya ng iba't ibang klase ng decay. Halimbawa, dun sa alpha decay, kasama din po niyan ang gamma decay. Paano ba nangyayari yung? Tignan niyo po yung example natin kanina, ito lang po yun. Diba, sabi natin, nag-produce siya ng panibagong element, nag-produce siya ng alpha particle. Aside dun sa dalawang na-produce, nag-produce din po siya ng tinatawag nating alpha particle na nagdadala po ng energy. Other than that, so you have carbon-14 that turned into nitrogen-14 on which nag-release po yan ngayon or nag-eject yan ng isang electron at nag-produce ng isang gamma particle. And for the last example po natin, ayan, kagaya rin na to. So we have uranium-238. It would become thorium-234 on which nag-release yan ng alpha particle. And aside sa alpha particle na yon, tingnan niyo po, nag-release din po yan ng isang gamma particle. And for the last one, ito po, mostly gamma decay lang yung nangyari sa kanya. So from thorium-234, kapag nag-undergo ng gamma decay, thorium-234 pa din siya. The only difference is that nag-release po ngayon siya ng tinatawag nating gamma particle. Ganun lang po ang different types natin ng tinatawag nating radioactive decay.